Welcome to SC2Gate. We are doing Radian Measure today, types of questions, focusing on arc length and area of sector. Okay, I'll just be going through the exam questions. So here we go. Okay, the following question comes from an exam paper. The diagram below shows the cross section of a cylindrical tunnel of length 300 meter. A level surface HK is laid inside the tunnel to carry vehicle, and the space below HK is filled with rubbles. Okay, now center is O and reflex angle is 4 pi over 3 radian. Perimeter on the major sector. So at first glance, this actually is a radian type of question. Okay, I hope you'll be able to see that because they give radian angle and then there's a circle. So if you cannot see the 3D, you have to visualize it. If not, you have problem with part 2. Not maybe no more, not so much with part 1, but you have problem with part 2. Now, if I extend this, okay, so part 1 is just the radius. If I extend this length here is 300 meter. So hopefully you can see better what it means. So there's a lot of rumbles up here where they fill in the road so that it become a base for the vehicle to travel on. So now we want to calculate the radius of the tunnel. Radius is HOOH or OK. Those are the radius. So what can we do? Now, what is given to us? Perimeter on the major sector HOK. We know this. HOK. Now, if you don't know which part it belongs to, take a look. It says major. That means it's the bigger side. That means it's this one. From here all the way to here, including the two radius. Okay? If it says minor sector HOK, then it's the other side. Okay, so major sector, so this is the big one. And they said this perimeter is 49.5. 49.5. And if we minus away the two radius, which is this part here and this part here, then that will give me the arc length of this major sector. Now recall your formula. S equal R theta and area equal to half R square theta, which is the two formula given to you in your textbook. Now area not so applicable here yet, but we can use the arc length, which is this. So am I right to say the arc length r theta plus 2 radius? Right, this is the arc length, the curved part, plus the 2 radius would give me the perimeter of this major sector HOK, which is 49.5. And if we try to manipulate this a bit to find R, so on the left side we can take out R as a common factor. So theta plus 2R. No, 2. No R, R taken out. Equal to 49.5. So R equal to 49.5 over theta plus 2. So theta is the angle. What's the angle here? 4 pi over 3. Sub in 4 pi over 3. Use your calculator. 4 pi over 3 plus 2. Okay. And you should get your radius to be 7.9983 if we were to take 5SF. Okay, round off to 3SF, so it's 8.00 meter. 3SF. Please do not put 8. Okay, then it will not be 3SF. 8.00 because the whole number itself, the entire number itself is not a exact figure. We need to make it 8.00 to satisfy 3SF. Okay, so here we have it, the radius. Now I deliberately write out 35SF because I might need to use the R later on. If I need to use it, I will not use 8. I will use 7.9983. Let's continue. Part 2. Calculate the volume of rubble in the tunnel. Now, this is the rubble. So what we would do, I will find the area of this cross-sectional area and then I'll multiply by 300 meter. So now, my strategy is to calculate the area of the sector. In this case, this is the minor sector, the smaller one. So we have to change the angle to this side. Minus away the triangle that is this, and I will be able to find. So I'm going to find it part by part. First, I'm going to find the area of H. Okay. To make things very clear to myself as well, I'm going to draw the shape here. Okay, equal. Now the formula is A equal to half R square theta. Notice that we found our R earlier on. Please do not use 8. So half, if you remember the R we found earlier was 7.9983. Square it, and the theta has to be this one, not the 4 pi over 3. Now 360 degrees, one full circle is 2 pi, so it's going to be 2 pi minus 4 pi over 3. And this will give me the area of that sector. Okay, I'm just gonna do one more step before I press my calculator. Now 2 pi is actually 6 pi over 3, right? 6 pi over 3 minus 4 pi over 3, I'm gonna get 2 pi over 3. So it'll be easier to press the calculator now. I'm gonna press at one go, and this will give me 66.993 for 5SF. I'm not going to round off to 3SF because this is not the final answer and I need to use it. So I'm going to keep it as 5SF. Next, I need the area of the triangle. So I'm going to write it down. So area of triangle is still HOK. So it matters how you draw it, so that you don't get confused yourself. Now, this one easier to use half AB sine C. So half times the R, which is again being used, 7.9983. Half AB. So it's the R again. So I'm just going to put a square here. Half AB sine C, which is the angle, and it's 2 pi over 3. Remember to change your calculator to radian mode if you are using trigo sine. Because you're not using degree here, this is radian. So please, if you do not change to radian mode, it's going to affect your answer. So just press this into calculator, you're going to get 27.697. Again, this is 5SF. To satisfy them, I need to find the cross-sectional area of the rumble. Cross-section area of rubble. It pays off to be more systematic in your working. Not only the examiner have a better time and an easier time to mark your work, you will also have an easier time to check your work. So it matters. Minus away, so 66.993 minus away 27.697. So I get a cross-sectional area, which is 39.296. Okay, this will be in meter square already, but I want the volume. Sorry, no, they want the volume. So volume is equal to this number, 39.296 times your 300 meter. It's going to be 117,888 and so on meter cube. Now, this is not exact, there's some more numbers behind. So we will put it as 3SF because this is already the final answer that they want. 118,000 meter cube. Please bracket 3SF. Okay, this is quite a standard question. We're going to get into something harder and harder. Alright, next one. The diagram below shows the sector OABC of a circle. Center O in an isosceles triangle OCD. Now OC equal to OD equal to 10 and COD equal to 1.2 radian. Very good. Seems very clear. It's again a radian measure kind of question. Find the area of the shaded segment ABC. Now, if you look at ABC, the shaded segment, now that is not a regular shape. This is quite a weird shape. It's not a semicircle either. So you can't find it directly. The best way is to find the sector ABCO. Okay, if you cannot see, I'm going to draw it here. The sector O is a bit ugly. ABCO, and then minus away this triangle ACO. Then you'll get the ABC, that shaded region. So sector, don't need to write major because that's all there is that is appearing on your diagram. Sector, but it do pays to write it out. ABCO. Okay, area is equal to half r square theta. Remember the formula? Half. Now, do we have our r? Yes, we do. Is given as 10. 10 square uh, theta. Do we have the theta? This part here, we don't have. But this is a straight line. A straight line means it's 180 degrees, which is pi. So is pi minus 1.2. Okay, calculate this. Alamak, I don't have this half calculation. Okay, maybe I don't calculate first. You can press your calculator if you try and then try together. Now, area sector ABCO. Then I'm going to calculate my triangle first, and then I'm going to do it one go later on. Area of triangle ACO, half AB sine C. That's my choice. So half AB. A and B is the two sides, which is AO and OC. That will just be the radius, which are not really radius lah. In this case, just 10 lah. Okay, so again, it's 10 square because it's 10 times 10. And then sine half AB sine C, sine again this angle here, which is pi minus 1.2. Okay, so I'm going to put this away. So the final answer of the shaded segment ABC is equal to half, which is bigger, the sector is bigger, yes. Half 10 square pi minus 1.2 minus half 10 square sine pi minus 1.2. Sorry, it looks a bit small in the back. Can. So you can see that there's a lot of common term. That's why I wanted to leave until the end before I press the calculator. So 10 square, take out all the common terms. So it becomes half pi minus 1.2 minus sine bracket pi minus 1.2. Okay, then I press at one go. Then I will get the answer 50.505 cm square. Again, this is 5SF. Cut it down, it's not exact, cut it down to 3SF, so it's 50.5 cm squared. You get it? Okay, next. Part 2, the length of CD. This one. Now, notice that this not really radian measure anymore. I mean, other than the fact that the angle given is in radian. Can you see that this is more of a, you can use cosine rule to do? In fact, I will use cosine rule to do. CD square is equal to 10 square plus 10 square minus 2 times 10 times 10 cosine this angle 1.2. Again, let me just remind you, make sure you change your calculator to radian mode in here. If not, your answer will be very strange. Okay, so my CD square, after I press into the calculator, I'll get 127.528. And then I square root. I'll be two answer, positive and negative. You just take the positive one because it's a length, cannot have negative answer. 11.29 blah blah. And then it will become 11.3 cm, 3SF. Now notice that question on radian sometimes are not standalone. They will be combined together with topics like trigo. Sometimes they also get involved with topic like volume, area, all this. So these are things that's just take note lah. These are sometimes it's not just radian measure. So don't just think of one approach. There can be many approach. Okay, so very easy way. We just found CD. Next question. Now this question is a bit hard. Don't need to feel so overwhelmed. This was from quite a good school. So sometimes it takes you to read for quite a while. Okay, so let's read it. WXYZ is a rhombus. Now, What is a rhombus? A rhombus is where all the sides have the same length, but it's not a square. Okay. Area of 97.5 cm square. They give you the area of the rhombus and a diagonal xy. Now this xy is 15. It's not so clear here. I'm just going to write this 15. And then there is two sector. Can see this? Oh, it's like a circle, a sector of a circle, and the other side. Find the angle WZY in radian. WZY. They want this. Now it's a bit hard because you don't have WZ or ZY, which is the radius of the sector. You also don't have the area of this. All you have is the area of the rhombus, which is a bit hard if you don't know the properties of the rhombus well. Okay, so in this case, the 15 actually plays a very important part. Now, one of the very important property is the two diagonal will meet in the middle. That means if I were to draw a straight line again from W to Z, Y, sorry, and so I just assume as a straight line, all the way to Y, this will the W to the middle point will exactly be half of the other side. So it's being half. I think that's quite obvious to you. Another thing that might not be so obvious is this intersection here will always be 90 degrees. This is one of the most important point in the rhombus, especially this question as well. So now, if we know xz is 15, what is, let's call this middle number A or C, maybe C is nicer, center, C for center. Let's call it C. Okay, maybe I can erase, why I don't erase? Okay, C. Center C. So if center C, the whole xz is 15, then zc would be 7.5. Now, what would this triangle ZWX be if I want to find the area? Wouldn't this WC be the height and then the whole XZ be the base? Yes, and times 2, I will find the full area of the whole rhombus, which is given to me. So I can work backwards to find the WC height. Okay, let's try to find the area of this triangle WXZ first, so as not to confuse our audience. All right, triangle WXZ area. Half base times height. Okay, which is I'm using XZ as the base, so this is 15. And the height I'm using WC, which is what I always trying to, the whole purpose of this exercise. Now, I'm just going to keep it like that because I don't know what's WC anyway, and I don't have the area of this. But I do know area of WXZ times 2 will give me the area of the whole rhombus. So if I times 2, this half will go away, right? So it's as good as saying 15 WC is equal to the area of the whole rhombus. I hope this is not too fast for you, because I do jump one step from here. It's not really jump, just like I can say, then write out detail. You can try write it on your own. This whole area times 2 will give you the area of the rhombus. Okay, then you can see whether you get the same thing. So WC would be 97.5 divided by 15, which give me 6.5. And it makes sense. 6.5 cm. So this length here is 6.5. Now, can you see there's a triangle that is forming up? Something like this here. W, C, and this is Z. And this is a right angle triangle. So here is this theta. Let's call this theta. Okay, and then this is 6.5 and this is 7.5. And I can use basic trigo to find the angle theta. So tangent theta is equal to 6.5 over 7.5. Now notice here we want it in radian. So again, please, if you have not changed your calculator radian mode, please change your calculator radian mode especially. So theta equal to tangent inverse 6.5 over 7.5. Press the calculator and you will get 0.71409 for 5 SF radian. This is not the final answer, that's why I don't bother to change to 3 SF. And then the question asks for angle WZY, which is the whole thing. So yeah, I need to times 2. So 0.71409 times 2. Okay, this is very bad working. I shouldn't write it this way. I should write what I'm finding first, which is angle WZY. Okay, times 2 1.428, which will be 1.43 radian. Correct to 3SF. If you can't see at the start, doesn't really matter. But I also took quite a while, so it's fine. This is not considered a simple question. It's quite hard to be able to see the right angle triangle from there. Okay. Anyway, 1.43 radian. Next part, find the area of the shaded region. Now, just to recall what we have this length here all the way to the center, which is 6.5. From here to the center is 7.5. Now, it will be very useful to find the sector radius, which is WZ. So I want to find this first. So WZ, using Pythagoras theorem, WZ square, uh, maybe don't square, just put WZ and square root, is equal to 6.5 square. Sorry, the 6 looks not so nice. 6.5 square plus 7.5 square. Okay, press your calculator, you will get 9.9247. That's the radius WZ. And this side is also the same because they said it's a rhombus, so there are two sides the same. And this is the sector. Now, I want you to see how is the area of the two sector intersect to give this gray area. If I were to add the area of this sector and the area of the other sector together, okay, and minus away the area of the rhombus, this part here will be the excess. And that's how you do it. So 2 times the area of the sector, which is half r squared theta, 9.9247 square r squared. Then my theta is, oh, what's my theta earlier? My earlier theta is where did the answer go? 1.428. Yep. So this is the two sector minus away my rhombus area, 97.5. That would give me the answer, which is the shaded region. Okay, 2 times half I can just cancel because it's 2 times half will give me 1. So it's just 9.92 times 47 square minus etc. Otherwise, you can just press calculator at one go and you will get 43.158. 3SF, 43.2 cm square. Alright, we have reached the end of the video. I have gone through about 3 questions so far, 3 exam questions in other school exam papers. So I hope you have a better understanding of how you apply circular measure in terms of radian and so on. And you see that it actually is usually combined with other topics such as trigonometry, etc. So thank you. See you again.